What is the difference between lizards and salamanders? Lizards and salamanders are among the most successful animals around today, and they've been around for hundreds of millions of years. This longevity, combined with a few superficial similarities, often sees these two animal groups compared to each other and in some cases mistaken for each other. That's why we've decided to step in with today's video as we go over all there is to know about these critters. Our primary focus is clearing up the confusion between lizards and salamanders to prepare you for the next time you encounter one or the other. With that out of the way, let's get rolling. Lizards. In the simplest terms, lizards are reptiles from the Squamata order that are not snakes. However, there are some complexities involving their classification, as some lizard species are actually more closely related to snakes than to other lizards. All in all, there are more than 7,000 species of lizard today. Most are four-legged with tails, but there is a subgroup called Amphisbaenia, which is mostly made up of legless lizards. Lizards are the most widespread and diverse reptile group on Earth, making up about 60% of all non-avian reptiles alive today. They're found on all continents, bar Antarctica, and many of the world's islands. They range in size from the aspirin-sized nanochameleon, Brucessia nana, to the 330-pound Komodo dragon, Varanus komodoensis. Most species are carnivorous, although a few are herbivorous and omnivorous. For the carnivores, diets include anything they can catch and overpower. Smaller lizards typically eat bugs and small invertebrates, while larger ones add vertebrates like birds, rodents, and other reptiles to their menus. Huge lizards like the Komodo dragon can even go after large mammals several times their size, like deer, pigs, or humans. When it comes to hunting, lizards generally employ an opportunistic right place, right time strategy. Stealth-aided ambushes are a common tactic, as many predatory lizards have skins that blend in well with their surroundings. Some lizard groups, like chameleons, can even manipulate their skin pigmentation, allowing them to blend in with different backgrounds. Of course, most lizards are seldom ever apex predators in their domains. Depending on their size, they have to worry about other reptiles, birds, fish, predatory mammals, and sometimes humans. Small lizards also need to watch out for extra-large invertebrates, like scorpions and giant spiders. As you already know, lizards have a long history with humans, mainly coexisting alongside us and staying out of our way. However, large lizards like Australia's Megalania competed with humans for prey, while several other species have been hunted for food. Nowadays, numerous lizard species like the bearded dragons of the Pogona genus have grown in popularity as pets. In the opposite vein, species like monitor lizards are notorious pests that often plague livestock owners. Lizards have been around for a very long time, but there is plenty of debate regarding how long exactly. The oldest fossils of what paleontologists call true lizards date back to the Middle Jurassic, about 174 to 161 million years ago. The fossils were found in various parts of Europe, Asia, and northern Africa. By the time the Cretaceous period rolled around, lizards had spread all over and diversified. They even spread out into the water and spawned clades of aquatic reptiles, the most renowned of which is the Agilosaurs, a group that would later evolve into the infamous mosasaurs. During the age of the dinosaurs, lizards, especially those with terrestrial abodes, would have had to scrap whatever living they could under the shadow of the titanic rulers of the earth. Some would have hunted insects and small invertebrates, while larger ones hunted dinosaurs smaller than them or even raided eggs, much like how monitor lizards steal crocodile eggs today. Scavenging leftover kills was also an option, since there was an overabundance of predators, big and small. Of course, with countless threats on the ground, in the water, and in the air, lizards had to take special care not to end up on someone's menu. To counter this, they would have relied on camouflage, burrowing, and arboreal adaptations to stay out of trouble. Others, like ancestors of modern iguanas, would also seek refuge in the water and develop crazy swimming skills. Much speculation surrounds how lizards survived the great extinction event that marked the end of the Cretaceous period and the rule of the dinosaurs. The general consensus is that a combination of luck, being small-bodied, sheer diversity, and the ability to seek shelter underground and underwater allowed them to recover from events that wiped out the much larger dinosaurs. Burrowing would have been especially useful for snakes and lizards' ectothermic needs. Remember, lizards are cold-blooded, so they need to manually control their own body temperature by moving to warmer or cooler places. Post-disaster, the world was largely characterized by fluctuating temperatures, but the surviving reptiles and their eggs used the ground as a refuge from extreme heat and cold. Another good thing about the end of the dinosaurs, at least as far as the lizards were concerned, was all the juicy rotting corpses on offer. Large titanosaurs, triceratops, tyrannosaurs, beached mosasaurs, it goes on and on and on. Lizards finally had an opportunity to get some overdue payback on their old overlords. You have to remember that the end of the dinosaurs wasn't just an overnight thing. Many of the dinosaurs actually died because of secondary factors like reduced oxygen levels and habitat loss. So, lizards likely feasted on an ever-shrinking pool of dinosaurs for centuries, if not thousands of years. In the intervening years, they've only gone from strength to strength, enduring through ice ages and witnessing the dawn of man. Naturally, humans inevitably ended up putting a spanner in some of that expansion through direct persecution or habitat destruction, resulting in many extinctions and even more endangerments. Salamanders. Again, in the name of simplicity, salamanders are best described as lizard-like amphibians. That's right, salamanders are amphibians, not reptiles. Any lizard-like qualities are a result of long-distance common ancestry and convergent evolution. That means they are much more closely related to frogs and toads than to lizards and snakes. Salamanders make up the Urodela order of the amphibia class. Fun fact, Urodela is actually ancient Greek for conspicuous tail, one of the major salamander traits. Limbs are another common trait, but a few fully aquatic species lack 2 or all 4 legs, and some may have fins instead. All in all, there are approximately 760 salamander species today, divided among 10 families. Most salamanders are largely native to the northern hemisphere, with North America being home to about 33% of known species. A few salamanders are native to the lush jungles of South America, but interestingly, there are no salamanders native to the diverse ecosystems of sub-Saharan Africa and Oceania, something we can't say about lizards. Like lizards, though, they are a very diverse group of animals with shared and unique survival skills. They range from the thumbnail-sized, minute salamanders of the Thoreus genus to the 6-foot Chinese giant salamander, Andreas davidianus. One of the most iconic salamander superpowers is the ability to regrow and reuse limbs and vital organs like the jaws, spine, and even the heart. This ability has been the subject of intense scientific study, as applications would be a massive game changer in medicine and maybe even warfare. Some salamanders ooze poisonous skin secretions that give predators pause, while others are camouflage experts that blend in to hide from their hunters and hunted. Skin is one area where salamanders are markedly different from reptiles like lizards. Mainly, unlike lizards, salamanders do not have scales on their skin. Most have wettish, smooth skin, like many frogs, while a few others have leathery, warty skin, like some toads. But scales? Never. As a result, most salamanders are heavily dependent on bodies of water and moist environments. Otherwise, they risk cracking up. Lizards, even those of aquatic persuasion, are generally more comfortable with terrestrial life away from the water than salamanders. Unfortunately, salamanders cannot change color at will like chameleons. However, color changes sometimes happen. Male newts change color during breeding season, for instance, and the transition from larva to adulthood often comes with a change in color, which brings us to another interesting fact about salamanders. Most species have an aquatic larva stage followed by a transition involving dramatic changes. Salamander larvae, which look like tadpoles with little arms and legs, swap gills for lungs and advanced tail fins for lizard-like tails when turning into adults. Most reptiles, including lizards, generally hatch in their final form, albeit a tiny version. When that final form does come in, it has a few other differences from lizards. The toes, for example, lack claws, a standard feature on most lizards. Different salamanders have specialized feet and toes for swimming, climbing, and walking, but all of them are blunt. What salamanders rarely lack, though, are teeth. Almost all species sport small teeth on both jaws. Salamander teeth work in an interesting way, using a concept kind of similar to arresting a criminal suspect. Cooperation makes the process smooth, but resistance is met with force. In practice, the flexible teeth bend backward toward the throat, making swallowing victims easier. However, if said victim tries to wriggle to freedom, the amphibian's teeth stiffen against the resistance, keeping the captured animal in place until it's ready to cooperate or die fighting. Lizard teeth, in contrast, are quite varied. Many are used for the same grip-based hunting strategy used by salamanders, while others are specialty cutting tools for ripping flesh. Herbivorous lizards, meanwhile, have teeth adapted for grinding up and chewing plant materials and fruit. Interestingly, salamanders have been around longer than lizards, having emerged sometime in the Middle-Late Triassic, about 218 million years ago. However, they can trace their lineages back to ancestors that diverged from lobe-finned fish of the Devonian period, roughly 360 million years ago. Modern salamanders' direct ancestry lines run back to the mid to late Jurassic, which suggests that conditions at the time facilitated convergent evolution for salamanders and lizards, hence why they look so similar today. However, unlike the lizards, most prehistoric salamanders had a greater affinity for life near water, which would also explain why they are not so widely distributed as lizards today. Other notable differences. Almost all salamanders are capable of body regeneration, and that includes the regrowth of highly complex tissues and organs. Some lizards can regrow their tails, while an even smaller few can regenerate parts of major organs. Distribution is another big difference. Lizards live pretty much everywhere, apart from the polar regions, while salamanders' native ranges are largely restricted to the northern hemisphere, which has many more moist terrestrial environments. Lizards also have scales that allow much better water retention than the porous skin of salamanders, which are much more heavily dependent on water access. Next is breathing. Most adult salamanders breathe and respire via lungs, skins, and oral lining, while a few other species lack lungs altogether. Juvenile salamanders breathe through gills. Lizards, on the other hand, keep it simple by breathing through lungs. Then we have reproductive differences. Most lizards lay shelled eggs on the ground or underground, while a few others give birth to live young. Salamanders, meanwhile, do not have shelled eggs and may lay their broods in the water or on land. Species that reproduce in water have aquatic stages, while land layer species do not. Then we have favored times of activity. Almost all salamanders are exclusively nocturnal, likely to avoid the harshness of the sun. They have several nocturnal adaptations, including highly developed night vision peepers. On the other hand, the overwhelming majority of lizards are active during daylight hours, with the exception of geckos, but those guys are weird anyway. Lastly, let's look at diet. Though mostly carnivorous, some lizards are omnivorous or even full-on vegetarian. There's no such variation among salamanders, which are 100% carnivorous 100% of the time.